Okay, thank you. So good afternoon, everyone. So my name is Iskandar Setiadi, and I'm glad here to be in the first ever PyCon in Indonesia. And the topic of my talk is actually my side project, so it's actually for fun. Deep learning in Python, image recognition for any characters with transfer learning. But actually it's about image recognition in general, how you can do image recognition in Python easily for a lot of purposes. So a bit short profile from me. I'm currently working as a software engineer in Japan, SDE. And you can access my GitHub profile, Freedom of Kema, and my website in https://freedomofkema.com. So my hometown is Jakarta, and I graduated from Institut Teknologi Bandung in 2015. And I was also a speaker in PyCon Japan this year. So why do I like to use Python? The first one, Python is probably like the easiest programming language to use compared to Java, C++, and other languages. And Python has a very great community, such as the organizer of this event. And Python is a Swiss Army knife. You can use Python for a lot of things. In my company, we mainly use Python for website development. Actually, the previous session in auditorium room by Jonas is also about async.io, which is from my team. And you can also use Python for data science stuff. Talking about image recognition, so what can we actually use image recognition in our daily life? For example, Tesla, they created a self-driving car, so they use image recognition to analyze and to detect the traffic and the objects which is in the road. And you can also use image recognition for the smart home. If you know, like last year, Mark Zuckerberg, he created his own Jarvis for home. So when someone comes to his house, it will be integrated with his Jarvis and it will send to his Facebook Messenger. And the left one is actually from Microsoft presentation. They trying to make a smart workplace with image recognition. So you can detect where the workers are located, you can detect where the tools are located, and it will be integrated with their Azure system. And recently Apple, they released the iPhone X, which is integrated with the Face ID system. So the background of this talk is actually, okay, I want to attend PyCon Indonesia, right? So I need to find something to talk because I cannot use the same talk with my other teammate. And at one point I decided to learn about image recognition, which is a very interesting and promising stuff because a lot of things can be done with image recognition. So I decided to try to solve one of the problems that I usually face in my daily lives. If you know, for anime characters, there are several websites that try to create an index of all characters which are in the internet. But the problem with this system is if you have a crop image or you edit the brightness or the contrast of the image, the indexer will not work and it will not give the correct result. So, for example, at the top, it still correctly detected the characters, but at the bottom side, it cannot detect the character. Or the other problem is you have a character from a photo, but since a photo is usually not or official or a fan art, so the image indexer cannot detect the character properly. Okay, does anyone here ever try to do image recognition in Python? Anyone? Okay, so probably you ever heard about ILS-VRC. This is the largest computer vision competition in the world. Deep learning is actually started to popular in the recent several years. If you see from this graph, it started to popular from 2012. And starting from 2015, deep learning actually has a better top 5 error rate score compared to human being. So human tends to make around 3% of mistakes in classifying objects. And right now, deep learning can actually do it better. So what is the actual challenge of image recognition? there are a lot of things that we need to consider, starting from the object scale, the number of instances in one image. There's also the problem with the color, the shape, and the real world size. So for example, from our human eyes, it's probably easy to distinguish between the size of or the color of the object. But for computers, it's more harder. Why? So if you are new to machine learning and image recognition, I suggest you to try this TensorFlow tutorial about MNIST, which is training to detect handwritten character. So in computer, the character 1 is usually represented in an array of numbers, such as this, as you can see. And this tutorial provides you with around 55,000 training data, 5,000 validation data, and 10,000 test data. When you represent this problem, you get the following neural network graph. You have x1, x2 as the input, which is the number which is shown here. And then you want to train your network to get the value of the weight and the bias value, and you apply the softmax layer to get the output. Whether this is the confidence level of this character is actually a number 0, number 1, number 2, until number 9. So we have 10 output here. And for the input, it's the image size. So it's 28 times 28 pixels, around 700. To start with TensorFlow, it's very easy. You can do it with PIP, just install the TensorFlow, or if you have GPU, if your computer supports GPU, you can use the TensorFlow with GPU, because it's a lot faster, like 10 times faster. Now, how you represent a model from the previous image in the Python code? With TensorFlow, it's actually very easy. For example, in the previous image, we have like x1 until x784. You can represent it with x is equal tf dot placeholder. The size is specified there. For the deep learning network, you specify the weight and the bias in this way. And for the softmax layer, you don't need to implement the details by yourself. You can just use the implemented version from the TensorFlow, and you can use it directly. So with this challenge, the result is shown here. With the multi-layer neural network, you can get like around 91% of accuracy. But when we apply deep learning to the same problem, you can achieve up to 99% accuracy. But the problem with deep learning is because there's a lot of parameters to learn, it is usually very slow. Without GPU, it needs almost 1 hour to run. But when we use GPU, it's only take like around 6 minutes to run. So the problem with the traditional machine learning is when you increase the number of iterations, it usually will get stagnated at one point. So no matter how you increase the number of iterations here, it will stop learning new things. With more layers or deep learning, it works better, but the problem is usually it's very slow if you don't have enough computation power. So talking about deep learning, we will see the basic of convolution. So for example, if we have a shape like this, it will be represented in that way. And in that image, you can see how internally the deep learning filter or kernel tries to learn from an image to the convolve feature shown there. So actually the previous image, this line is taken from that small cute mice. And the actual visualization actually looks like this. It's more complicated because it has a depth of the layer. For when we want to do the face recognition, the first thing that we need to do is to detect or localize where the face is located. So initially when you detect the input image, you detect where the face is located, and after that you need to transform the image to make it like an equal size so that you can compare it with the others, and you pass it to your neural network, and you can do a lot of things. You can do clustering, you can do similarity detection between two faces, and you can do classification. To start with, it's very easy. There's a lot of open source tools right there. This one is adapted from face detect library, and it can be done only in 5 lines. You can import CV2, create the classifier from an XML model, read the image, and run the classifier. Run the detector, and the result is like this. When I try to apply this 5 lines code to this image, I got this following result. Okay, now this is the interesting part. I tried to run the same code to anime characters, but it doesn't work. It only can detect one box in the middle, and the other characters are not detected properly. So why? The reason is actually clear, because the facial features between anime character faces and human faces is totally different. For example, yeah, in anime characters you cannot, probably they don't have a noticeable nose, right? So that's a problem where you need to know how to learn from your dataset. You need to create a model which can solve your own specific problem. So yeah, you need to train a new model. But fortunately, someone else already did that for me. So I don't need to train the new model. You can access that library up there. It's created by a Japanese person, Naganomi. The other code is still the same, except the model, which is created, the XML file. So now, if I run the same model to the previous images, it can detect all faces correctly, even though there's some false positives. But overall, it works well. And when I run the same model to human face, it shows nothing. Okay? So now, for face recognition problem, we can already localize and detect where the image is located. And now, before I already talked about the problem with deep learning, right? It requires a huge dataset, and Google itself, when they created the Inception V3, it took around 1 week to train the entire 1.2 million training data for 1,000 classes as the output. This is probably very complicated, and I probably will not explain it in detail, but the Inception V3 layer looks like this. It has a lot of layers, a lot of convolution layers, but basically the idea is those layers will learn from starting from detecting edges, detecting the higher features such as shapes before running it into the classifier. If you remember in the title of my talk, I talked about transfer learning. So the transfer learning is pretty useful if your dataset size is small. In this case, why I use transfer learning for this problem is because in the anime characters, the top 5 characters has the number of dataset is very small. For example, the top 2,000 characters only has probably around 40 images per character, but they have more than 30K registered characters. So with transfer learning, the idea is we don't need to retrain the low-level features. So we don't need to retrain how to detect a proper edges from anime characters. We don't need to learn how to detect shapes from anime face characters. So the idea is you have characters, you resize it to the same size, and the transfer learning will only learn the last part, where you relearn the fully connected layers and you learn the softmax, or the last layer which makes the prediction. So the softmax layer, which is shown before, it is used to, for example, if you have 2 classes and each class has, the class A has a value of 0.95, then class B will have the value of 0.05. So it shows the model confidence level in detecting a specific face, whether this face is actually class A or this face is actually class B, and they will sum up to 1. So to retrain the final layer, if you are using TensorFlow, it's actually very easy. You only need to use Bazel. You build the retrainer with 1 command line, and you can execute the retrainer with another 1 line command. And after that, you can play with a lot of deep learning parameters such as learning rate, the number of iterations, and many others. So for those people who already played with machine learning, probably they always have this problem working with classifiers. It's like very, very annoying, and because yeah, it takes like a whole hours to run, and when the run ended, it's probably give like a very bad result, right? Okay, so after we get the final model, now I want to create a web application for my problem. So here I'm using Scenic, probably we will have another session about Scenic, yeah, by the end of this day. So if you are interested in using Scenic, the idea of this web application is easy. You load the model, run it into the TensorFlow, and that's it. So this web app specification is actually what it does. It will run the face detection with OpenCV, and it will resize the image to a fixed proportion before running the classification with TensorFlow. This web app is actually pretty, how do you say, you can deploy it anywhere because we already have the learn model. When you learn a deep learning model, you probably need a huge GPU resources to run. So I just throw it to Amazon Web Services with G2.2x large instance, and I use the pre-trained model in a very small server, like the web app is only like G2 micro. This is the Python code to classify the resized image. As you can see there, I load the model before into the tf.session, and I load the final result layer from the model which is created, and I read the image and run the predictions, get the top 3 predictions and sort it. So now you can see the result. I have an input image. It will read the image, resize the image, and do the classification with the 3 top predictions. Does anyone know this character? No? Okay. Yeah, basically it says this image probably has the name of Teddy Zarise with a confidence of 0.89. After that, I tried to play with number of class. I'm curious to see what is the correlation between number of class with the accuracy which is created. So with 100 class and 60 images, it gives me like 70% top 1 accuracy. But when the number of class that you want to detect is small, less than 35, it can give more than 80% accuracy for the top 1 accuracy. And after that, I also tried to change the dataset size. I tried to run with 100 class and 30 images per class. It only gives me like 60.3%. But when the number of images are 60, it gives me 70.1%. So it's important when you want to use deep learning to have a proper data, like number of data before using deep learning. Otherwise, it probably will not give you more benefits compared to the normal traditional machine learning. So probably, yeah, the internet here is a bit slow, so I will probably just show you how the result is. So now I built like a simple web app here. I uploaded the image, and it will give me the predictions for each character faces which are detected from this character. And I tried to detect anime characters from a photo. It still gives the correct answer, albeit the confidence is a bit low. It's only like 0.32. And actually, there's still a lot of problems that is not solved. For example, when you have a character that looks like this, so you need to solve the problem where it cannot detect the face properly, right? So I guess like image recognition is actually a never-ending development problem, because you need to care about the image noise, about the rotation or the face position from an image, and there's also a problem with face expressions, like when the character has a closed eyes, and you need to solve characters which has multiple or hand-seen forms, and you need to solve about the brightness and contrast problem. So I show you why the neural network is easily fooled. For example, for a human being, we can easily see that these 2 images are actually a teapot, right? But when we add a 10% impulse noise to this image, it says the output label is biology, which makes no sense for us. And in that image, it actually says like a lot of things. For human beings, those images are probably making no sense. But actually, as you can see this image, it says comic book. So when you try to detect a comic book and you try to detect that pattern to your neural network, it actually will give the same result, even though those images don't make sense for a human being. So that's one way to fool the neural network. If you are interested in using image recognition and you don't need specific requirements, such as you only want to detect face expression for sentiment analysis, I suggest you to use online web services such as Amazon Recognition, or you can use Microsoft Azure Computer Vision API in the cognitive service, because they can do a lot of things which are pretty useful for you. You can do object and scene detection, you can do facial analysis, you can do face comparison between two images, and it can also do the facial recognition things. So at some point, I decided to try the Amazon recognition for the anime characters, and it throws me an exception. It says that request has invalid parameters, images must contain detectable faces. So that's why if your use case is very specific, you need to build your model by yourself. If you have a very low number of data, you need to use transfer learning, but if you have a lot of data, you can use or relearn the entire deep learning network by yourself. So for future references, I hosted several codes in my GitHub, Freedom of Fema, and this slide can be accessed from my website at /pyconid2017.pdf. And I suggest you to try checking these links out, because they have a very interesting curated list of how you can do image recognition. Let me show you. Okay, no internet connection. Yeah, so please check those websites by yourself. And finally, a bit promotion from my company. So if you are looking for a new internship opportunity or a full-time opportunity, please go to our website. Currently, our company has more than 15% of international people, and 6 of them are Indonesian. And that concludes my talk. Thank you for your attention.
Thank you very much. Oh yeah. I think we have some time for questions. So, okay, please.
Thank you, Dr. Tunisi. There is so many machine learning algorithm. Even in deep learning, you can use convolutional, you can RNN, and so many. Do you compare that or?
Yeah, I currently only
which
use
is the best?
Yeah, I can only use the Inception V3 because it's easily available via TensorFlow. So if you are using TensorFlow, the model is already there. You can use it directly. And I actually do this project for fun. So I don't actually have enough time to compare all of those models.
Do you have any suggestions? Which library is the best for if you want to build our own model?
If you are a beginner, I suggest you to try TensorFlow. But if you are already an expert, you can use other like Keras or Theano or other libraries. Because for me, the documentation of TensorFlow is good. They have a good documentation, like step by step, how you can install it, how you can run it.
Is there any more question for Iskandar?
Much more?
Okay.
For the resource, computations, because machine learning is very sensitive with computational resource.
Yes.
Can we use our daily use computer, notebooks, laptops for?
If you are patient enough to wait for the result, right? Okay. Yeah, because this is a funny thing. Like back in my university, I had like one of my friends. He's doing the final project in machine learning, and he did it like in the laboratory PC, which is like very slow, and it probably takes 1 week to run, and someone just unplugged the cable. And yeah, my suggestion is probably it's better to run it in a cloud services, and you can just found an instance which has TensorFlow or another library pre-installed for you. So you don't actually need to set up the environment by yourself, but yeah, it's a bit expensive compared to using your own PC.
Is there any more questions for Iskandar? I think Iskandar will still be around, right?
Yes, I'm still be around, and actually you can contact me directly in Facebook or email.
So you're coming directly from Japan here?
Yeah, I came here like yesterday afternoon. So I need to change my plane in Jakarta.
So thank you very much, Iskandar.
Okay, thank
Let's give
you.
a applause for it.